Hi guys, I will be going over penicillin. So, what is penicillin? Penicillin is a commonly prescribed antibiotic that is used to treat bacterial infections that are caused by Staphylococcus and Streptococcus, which belongs to the beta-lactam family of antibiotics, which all share a common mechanism of action that stops bacterial cell growth, which leads to bacterial death. The structure of bacteria. Bacterial cells have a protective covering called the cell wall, which is a key component of this wall is peptoglycan, which is a structural macromolecule with a mesh-like structure that adds strength and support to other cell walls. To build the cell wall, the peptoglycan chain connects with others through the action of an enzyme called the DD transpeptides, which is also known as penicillin-binding proteins. Throughout the bacterial life cycle, the cell wall along the peptoglycan crosslinks undergoes continuous remodeling to adapt the repeated cycles of cell growth replication. The penicillin's mechanism of action is that penicillin and other antibiotics with a beta-lactam family possesses a distinctive four-membered beta-lactam ring. The mechanism of bacterial eliminates by penicillin involves the binding of beta-lactam ring to DD transpeptides, hinders its cross-linking function, and limits the formation of a new cell wall. Deprived of a cell wall, bacterial cells become susceptible to external water and molecular pressure, which leads to rapid cell damage. The absence of cell wall in human cells ensures that penicillin selectively induces bacterial cell death without impacting human cells. Gram-positive bacteria are characterized by robust cell walls rich in peptoglycan, while gram-negative bacteria exhibits thinner cell walls with lower peptoglycan cells. The presence of the LPS layer surrounding the cell wall of gram-negative bacteria acts as a barrier. This embeds the entry of antibiotics, which consequently penicillin demonstrates optimal efficacy against gram-positive bacteria where DD transpeptide activity is more pronounced. So how penicillin can kill bacteria. Penicillin is a potential antibiotic that's effective in combating bacterial infections by disrupting the synthesis of peptoglycan, which is a critical component of bacterial cell walls. The selective of penicillin is erupted to its interference of peptoglycan production, partially in gram-positive bacteria that possesses an outer layer of this molecule. By inhibiting peptoglycan synthesis, penicillin induces structural weakness in bacterial cells. This compromises their integrity and making them permeable. This increased permeability, which causes bacterial cells to become fragile and prone to bursting. As a result, the immune system can more effectively break down and eliminate and compromise bacterial cells, expecting the healing process. Also, this targets the action against bacterial cell walls, which contains peptoglycan, which underscores penicillin's specificity for bacterial and its minimal impact on human cells, which lack peptoglycan. So how has bacteria now evolved? Bacteria, due to their rapid reproduction and vulnerability due to genetic mutation under antibiotic pressure, can develop resistance over time. Antibiotic resistance is fueled by factors like misuse and incomplete courses of treatment, which contributes to the formation of resistant superbugs that poses significant challenges for medical intervention. A common resistance mechanism involves bacteria producing beta-lactamase, which is an enzyme that renders antibiotics ineffective by breaking down their beta-lactam ring. An example of this is Staphylococcus strains, which have become more resistant to penicillin through this mechanism. However, bacterial such as metholectin resistant, the mRNA employs an alternative method, like upregulating specific penicillin binding proteins, which results in to all beta-lactam antibiotics and posing to a serious health threat. So the enzymatic inhibit mechanism of penicillin is that it works by stopping a vital process in bacteria. It blocks the action of enzymes called DD transpeptides, which bacteria needs to build their cell walls. The key part of penicillin is that it's a beta-lactam ring, which looks like part of the bacterial cell wall. When bacteria takes in penicillin, it sticks to the DD transpeptides enzymes and stops it by doing its job. Without this enzyme, bacteria can't properly build their cell walls, which causes them to become weak and eventually burst. Penicillin's effect is irreversible, which makes it a powerful antibiotic against various types of bacteria. So this is a 3D image of penicillin, which is actually pretty cool. But here are my resources, and hope you enjoyed my presentation.